We're on to the nephron loop. So reabsorption occurs in this loop right here, which is the nephron loop. This gets fun, which means a little complicated. I'm going to do this in at least 2 separate videos. So reabsorption, we've got a descending limb and an ascending limb. As you can see, the ascending limb is composed of a thin and a thick portion. There's going to be some different mechanisms in those 2 different portions. But throughout this whole loop here, this is looped down into where? The medulla. So this is in the medulla. We'll see that in just a minute. We're going to have reabsorption. So only things moving out of the nephron loop to where? To the blood. It's going to enter the either vasa recta or peritubular capillaries. So the descending limb, we're going to have water moving out. That's going to occur largely through osmosis, all through osmosis, largely through aquaporins. The ascending limb, we're going to have, I don't really want that long, also moving out. In this case, we're going to have sodium, chloride, potassium, a little bit of calcium, magnesium through passive paracellular transport as well. But these 3 kind of go together. These are going to be through secondary active transport and a special protein called the sodium potassium chloride cotransporter. 2-chloride is actually what it's called. It's got 2 of them. So we'll look at this. So the 2 things to consider when looking at what moves where are, is there a gradient for that thing to move? If not, we need to have ATP action. So gradients are going to be big. They always have been. And number 2, what proteins are there? So especially if you don't have a gradient, you need a protein to pump. But even for other ions, right, sodium can't move through the cell membrane without a protein. So these are the 2 things we're going to look at everywhere in the body, but especially here at the nephron loop. So how I like to start talking about this is having you try to make sense of what's happening in this loop, what needs to happen, make sense of it. So here is our loop, descending limb, thin and thick ascending, and I'm giving you here osmolarity, milliosmoles per liter. 300 is what we're going to start with for that filtrate, right? And you already know that. I've actually already shown you this before, right? That in that loop, osmolarity is going to increase to 1200, then it's going to decrease again back up to 100. By the time we get to our collecting duct, it's anywhere between 100 and 1200 via regulation at the collecting duct level. So if this change is occurring, what has to be happening in terms of solute and ion reabsorption? Well, it's what I already told you does happen. So going from along 1 here, what has to be happening? The filtrate is becoming more concentrated. We're going from 300 to 100 milliosmoles. So at number 1, we're having water reabsorption, which I already told you is what happens. And, but that should make sense. That's going to be what changes this filtrate to become more concentrated. As we go up the thin and thick limbs, our filtrate is now becoming more dilute. You see that? That's not because water is entering, because reabsorption is occurring here. We don't want to put water into our urine. at this point. We'll regulate that later. Right now we want to resorb everything, reabsorb. So we've got instead reabsorption of sodium, chloride, etc. Reabsorption. That happens via passive transport here and active transport here. That's going to result, if we have those solutes exiting the filtrate is going to become more dilute. So that's the principle I want to make sense. Regions 1, 2, and 3. The last thing I want to show on this image is the osmolarity of the medulla. So this is our interstitial fluid of the medulla. Actually, look at that. You can see where there's going to be a graph. I'm going to graph on this axis the osmolarity of the ISF in the medulla, because that's where we are. That's where the nephron loop is traveling through. Well, it's actually going to be equivalent to what it is in the nephron. So no big surprise here. But this is what's going to cause the drive for this change in osmolarity in the filtrate, is the osmolarity of the medulla. Our body can regulate the osmolarity of the medulla itself in the kidney, maintain that, and that concentration gradient in the medulla is going to be used to allow these nephron loops to function the way they do. So the last image I'll show in this first video here is an image of the medulla and the concentration gradient in the medulla itself, osmotic gradient. Osmotic gradient because we're going to use this concentration gradient, this osmolarity gradient, to move water. So it is a concentration of solutes, so osmolarity, right? So here is our nephron. Here's our cortex. Here's our medulla, and one pyramid you can see in the medulla. And then this feature I'm about to draw is a feature of the medulla. It's how the medulla is maintained. So I'm going to draw in those and figuring out a color to use here. Such a big choice. We'll do red. Notice this nephron is greatly enlarged. It's not really that big. They're tiny, tiny little things. So along this gradient here, what do we think we're going to start at in terms of osmolarity? What is it at the glomerulus? 300. So most of the cortex is 300 milliosmoles. This is all in milliosmoles is the units. We're going to start to increase right at kind of that border, 400, 600. You don't have to memorize where these are. The point is, oh, that's a 9. We've got to get to what? 1200. This would be where those juxtaglomerular nephron loops are going to dip down. So 1200 is what the medulla is here. And therefore, because of equilibrium and how that works, inside the nephron loop, it's also going to be 1200. So the osmolarity of the interstitial fluid of the renal medulla increases progressively from 300 near the cortex medulla junction down to 1200 at the medulla pelvis junction, the renal pelvis. And so it's going to be these juxtaglomerular nephrons with the vasa recta surrounding them that are really going to allow the nephron loop to do its thing. Versus those cortical nephrons, right? Those are up here. So not going to be the same function. Okay, make a pause here. We will dive into the proteins and put it all together in the next video.